Great, here are a few more examples of exponent rules all combined together. So we need to remember our order of operation. Order of operation, we have to follow our acronym BEDMAS. Do the brackets first. So whenever we have brackets like this one, I need to simplify the bracket before I can apply my exponent. Now within my bracket, I have some coefficients. So these are my coefficients. They're going to be divided. I have a base of x and a base y. So let's simplify it. 28 divided by 4 is equal to 7. Then I have x to the power of 1 minus 4. And for my y to the power of 1 minus 6. And all of that is still in the bracket, which is raised to the power of -2. So let's simplify. I'm going to rewrite it. 7 to the power of x. 7 times x to the power of 5. And I have y to the power of -5. And this is raised to the power of -2. Now, before I simplify my negative exponent, I'm going to use the power rule to incorporate -2 into my power. Okay, so I have 7 to the power of -2, x to the power of -10, and y to the power of +10. Now, the base 7 and base x has a negative power. That means that to make it positive, they need to be put in the opposite level. This was the this was the numerator, so now it's going to become the denominator. Y to the power of 10 divided by 7 squared x10. Okay, our second question, 3x to the power of 9, y to the power of -2 times x -6, y, all to the power of -2. Now, I need to simplify my bracket first before I'm able to use the product rule. So first, I'm going to apply the power rule for this part. I'm going to rewrite the first power, 3x to the power 9, y to the power of -2. And when I simplify it, I have x to the power of 12, y to the power of -2. The next step, I'm going to use the product rule. I'm using the product rule because I know that these bases are being these powers are being multiplied with these powers, and some of them have the same base. So I have 9 plus 12 for the exponent of x, and y, -2 plus -2. I'm going to simplify again. So 3x to the power of 21, y to the power of -4. But my question or my answer is not complete yet because I have a -4. I am going to apply the negative exponent. So that means that since this is in the numerator, it needs to be in the denominator now. 3x to the 21 divided by y to the power of 4. Our last question, we have 9x cubed all to the power of 4 times 9 to the power of 5, all divided by 9x to the negative 5, and close bracket, to the power of negative 2. Now, once again, we need to simplify the numerator first and the denominator before we're able to combine our numerator and denominator together. So in our numerator, we're going to apply the power rule to this first bracket. And in the bottom, we're also going to apply the power rule for our second bracket. So I have 9 to the power of 4, x to the power of 12, times 9 to the power of 5, all divided by 9 to the power of negative 2, x to the power of 10. The next step, I have these two powers that have the same base. I'm going to use our product rule to simplify it. So I have 9 as the base, and then 4 plus 5. And I rewrite 12, x to the power of 12, all divided by 9 negative 2, x to the power of 10. Now we're going to use our quotient rule. Quotient rule tells us that we can subtract our bases as long as subtract our exponents as long as our bases are the same. So I have 9 minus 2, and x 12 minus 10. That simplifies to 9 to the power of 11 and x to the power of 2.